Today, we're diving into a huge public health crisis. But what's really fascinating is the brilliantly simple AI-powered solution that's ready to tackle it head-on.
Okay, let's start with a number, and it's a big one. 5 billion baht. That's not a one-time cost. That's how much a single genetic condition costs Thailand every single year. It's this relentless drain on the healthcare system, just happening over and over again.
So you hear that number and you think, wow, that's a tragedy. But what if it's not just an unavoidable tragedy? What if it's actually a solvable economic problem? And here's the kicker. What if the tool to plug this massive billion baht leak is already here?
All right, so to really get why the solution is so clever, we first have to wrap our heads around the problem itself. And that problem is called thalassemia.
So what exactly is thalassemia? Well, it's a genetic blood disorder. But the key thing to know is that this isn't some super rare disease. Nope, it's incredibly common, especially in places like Southeast Asia. And if you have a severe case, we're talking about a lifetime of nonstop, really expensive medical treatment.
And when I say the scale is huge, I mean it's staggering. This isn't like 1% of the population. We're talking up to 40% of people in Thailand are carriers. Think about that. That creates this huge, stable genetic pool where the problem doesn't just fade away. It just keeps going, generation after generation. And that's how we get back to that 5 billion baht number. Where does all that money go? It's the relentless, lifelong treatment. We're talking constant blood transfusions, ongoing therapy. It's not a fix-it-once kind of thing. It's a massive, recurring burden, year after year, for the healthcare system and, of course, for the patients and their families. Okay, so at this point, you're probably thinking, wait a minute, don't we have screening for this stuff? And yeah, you're right, we do. But here's the thing, and this is the whole point. The way we do it now, it's just broken. It's deeply flawed, and it really isn't working.
Let me show you just how broken it is. The old way, it's slow. It needs all these extra, expensive tests. And get this, it can get it wrong up to 60% of the time. It's like a really messy, complicated recipe with a high chance of failure. What hospitals really need is something fast, accurate, and simple. Something that uses the ingredients they already have in the kitchen. And that massive gap between what they have and what they need, that's the opportunity.
So how do you fix a problem like that? Well, what's so cool about this is that the answer isn't some brand new multi-million-dollar machine. Nope, it's just a much, much smarter recipe. In fact, you can think of it as the instant noodle solution to a really complex problem. And that's exactly what this is. AI-THALASSEMIA. It's the healthcare equivalent of instant noodles. It takes that slow, complicated, messy process and makes it super fast, super simple, and accessible to pretty much everyone. And the genius here is really in the simplicity. Let's walk through the recipe. It's basically just 3 simple steps to get a perfect diagnosis. Okay, step 1, you need a pot and some water, right? Well, guess what? Every single hospital already has this. It's the standard blood test they run all the time, the complete blood count, or CBC. The data is already there, being created every single day. This is huge, because it means they don't have to buy a single piece of new expensive equipment. Step 2 is where the magic happens. We provide the seasoning packet, and that packet is a really smart AI algorithm. It doesn't need anything new. It just takes a look at that CBC data the hospital already has, and it unlocks all the crucial information that was hidden inside it all along. And step 3? You get the perfect meal, a super fast, incredibly accurate risk assessment that pops right into the hospital's system. You're turning boring old data into a potentially life-changing diagnosis in a matter of minutes. It's incredible. Okay, so that all sounds great in theory, but how well does this instant solution actually work in practice? Well, this is not just an idea on a whiteboard. The results are a total game changer, and believe me, the numbers do not lie. First up, and this is the most important thing, accuracy. We're talking about a model that is over 99% accurate. Let that sink in. Compared to the old way, that is a gigantic leap forward. Now, this next number is also super important. It brings a 60% improvement in what's called specificity. So what does that even mean? Basically, it means it cleans up that messy kitchen we talked about. It cuts way, way down on all those unnecessary follow-up tests and wrong calls that are bogging down the whole system.
And what does that mean for our hospital's bottom line? It translates directly into savings. You're cutting waste, you're saving precious time, and you're freeing up staff and resources to focus on other things. It just makes the whole operation so much more efficient.
All right, so it works. It's accurate, it's efficient. But let's zoom out and look at the really big picture here. How does this scale up from just one hospital to an entire country, or even the whole world?
Well, first off, the demand for this isn't some wild guess. It's totally stable and it's backed by national policy. In Thailand alone, you've got 700,000 pregnancies every year that need screening. That's a huge, consistent number. And this isn't just a Thai problem, right? This is a global issue, part of a market that's heading towards $500 million. And that's why you have to think of this technology as more than just a cool new product. It's really essential infrastructure. It's a fundamental tool for any country that's serious about tackling this preventable disease in a smart, efficient way.
So, the big takeaway here is pretty simple. The old way of doing things, that traditional, slow cooking method, it's broken. It's too expensive, it's too slow, and it's not accurate enough. Now, for the first time, a simple, scalable, instant solution is here.
And that leaves us with one last thought to chew on. This whole thing, it's not really just about thalassemia, is it? This whole approach, using smart AI to find answers in data we already have, it's a blueprint. It really makes you wonder, what other giant, hidden, multi-billion-dollar problems are out there just waiting for someone to invent their instant noodle solution?